We're looking at density today, and I'll just go through the questions with you. If you've gone through the PowerPoint, I think it's all fairly straightforward. Obviously, there's the added difficulty of something which is made of more than one material, and also you've got to know how to find the volume of an irregular solid by lowering it in water, etc. Eureka. Let's look at the questions, the end of chapter questions. Year 12. Question 1 is pretty straightforward. That's just rho equals m over v. Make sure you use a capital V because sometimes it's combined with velocity when we're looking at flows and so on, flows of air. Question 2 is it's the paint pot. So we've got the paint pot there, which has a diameter of 0.15 meters. The height of the whole pot is 0.12, which is 12 centimeters. But the height of the paint in there is slightly less. There's a 7 millimeter difference there, so that's 11.3 centimeters high, just to the top of the paint. Okay, then what have we got to do here? Well, if we find the mass of the paint is going to be mass of paint, which will equal, well, we know the mass of the paint and the can together, MP plus MC, that's 6.5, and we take away just the mass of the can, which is 0.22, and we get 6.3 kilograms approximately. Okay, then we've got B, which is pretty straightforward. B is just finding the volume, so that's going to be volume of a cylinder. So we've got pi d squared over 4. Pi d squared over 4 is volume, is area, times height. Okay, so instead of pi r squared, we use pi d squared over 4. You can use pi r squared if you want. That's equal to, so we put the numbers in there, 0.15 squared over 4, and we come out with roughly 0.002 meters cubed. Okay, so that's the volume. Then the density is just mass over volume, isn't it? Rho equals m over v. So we put the 6.3 over the 0.002, which gives us 3.1 times 10 to the power 3 kilograms per meter cubed. Question 3 is pretty straightforward. Okay, question 4 a little bit harder. Question 4, we've got this alloy. Remember that most metals are actually alloys. Very rarely use anything which is a pure metal, almost never. Copper, I suppose, in wires. Otherwise, things are alloys. We'll see why in another lesson. I think we're coming to that. So if we look at this, we've got the volume. Okay, we've got the volume is 1.8 times 10 to the minus 4, 60% aluminium, 40% magnesium by volume. Okay, so that 1.8 times 10 to the minus 4 meters cubed, if we multiply it by 0.6, that will give us the volume of the aluminium. And if we multiply it by 0.4, that'll give us the volume of the magnesium, 60%, 40%. Okay. Once we've done that, we can find the mass. So the mass of the aluminium equals the density times the volume of aluminium. And the mass of the magnesium is equal to, is going to be equal to density of magnesium times volume of magnesium. Okay, and those two numbers come out as, I'll just work this out somewhere, 1.08 times 10 to the minus 4, or, sorry, that's wrong, they come out as 0.29 kilograms and 0.2 0.12 kilograms. Okay, if you put the numbers in. And then to find the density of the alloy, the last part of the question, the density of the alloy. All right, so that's going to be equal to the total mass over the total volume. All right, so we've got both masses. We've got 0.29 and 0.12. That's the total mass of the total volume, 1.8 times 10 to the minus 4. And that comes out as 230 kilograms per metre cubed. Magnesium in an alloy, very reactive magnesium, yes, is used. It's used a lot as magnesium in, you sometimes hear about magnesium wheels on cars, and it means that the alloy contains magnesium. Okay, folks, it's a bit dull that one, I'm afraid, but I think you will all find it okay if you look through this a few times. So these are the end of chapter 4, end of chapter questions for chapter 11.